Welcome to the lecture series of Embedded Systems and Programming. So starting from the unit, Introduction to Microcontroller, let us start with the basics of ALU, that is Fundamentals of ALU. So ALU is a core computation unit within the processor microcontroller which is responsible for performing arithmetic and logical operations, and it acts as a calculator of CPU processing both binary data based on instructions from the computer unit. And in the industry concept, we can say that in Amazon warehouse robots, the ALU compute sensor data, for example, distance calculations for the navigations. So we know in arithmetic, we have the basic operations of addition, subtraction, multiplication, and division. So if take a, for example, we have take a two 4-bit operation operands, which where the operator is addition, and the value of 1010 is 10 and the value of 0101 is 5. So by adding these two binary data, we get the value of 1111, which is the binary value of 15. Same wise, it is a basic binary operations of addition, subtraction, multiplications. And coming to the logical operations, we have AND, OR, XOR, NOT, and also we have shift operations either left or right. So in the AND operations, we are going to perform the gate logics like in AND, we know that if it is true, only if both the bits are 1. And in the OR operation, the condition is true if either bit is 1. And in XOR, if the condition is true if bit differs. Whereas in NOT gate, the condition is inversion of the input bit. And in the ALU, we have flags like zero flag, carry flag, and sign flag to indicate the results used for decision making. And let us discuss about how the ALU works. And we can state it as a three stages like input, processing, and output. Whereas input, we have two operands from either registers or memory and an operation code, that is add. Or in the processing state, we execute the operation using combination logic circuits like either adders or gators. And in the output stage, we get the results and it is stored in the register, that is either accumulator or memory. Example, in an 8051, the ALU adds two numbers and the program code is move A. That is, we are going to move the A value in the address /05H, that is we are going to move the 05 data into the A register, and now the 5 will be stored in the A register. I'm going to add the A comma 03. Now I'm going to add the 3 to the A register. So what will happen is, initially I had the value of 5 in the A register. Now I'm going to add a new value, that is 3, to the value of A register. So initial value 5 will be added with the secondary value of 3 and the output will be given as 8. So here the major operands played is the instruction move and instruction add. So coming to the comparison of microprocessor and microcontrollers, these are the basic context and the definitions we can take it. So microprocessor is a programmable integrated circuit that serves as a central processing unit of a computer system, whereas microcontroller, it is a compact IC that integrates microprocessor core with the memory. So we can take a difference like in microprocessor, it is just a central processing unit, whereas in microcontroller, we have the microprocessor core along with the memory, that is either RAM, ROM, or flash. And in microprocessor, we have general purpose processing unit that executes instructions from the program stored in external memory, whereas here it is designed for specific embedded applications with the minimal external components. And in microprocessor, we don't have inbuilt memory, whereas in microcontroller, we have inbuilt memory like ROM, RAM, external also we can interface. And microprocessor need an external interfacing of the memories and to compute these complete function. And we can take example like for microprocessor, we have Intel 8085, 86, and ARM Cortex A series, whereas for microcontroller we have 8051, PIC microcontroller, and ESP32. So for a crisp comparison of microcontroller and microprocessor, first we go with the definition, that is CPU on a chip which requires the external components, whereas my controller is a self-contained system with both CPU, memory, and peripherals. And coming to the memory part, microprocessor we have to go for an external memory, whereas microcontroller has an inbuilt memory. And coming to the input output ports, microprocessor again it's need an external input output interfacing, whereas microcontroller it has an inbuilt input output ports. Coming to the power consumption, microprocessor goes with a higher consumption, whereas my controller it is a lower consumption and it can be optimized according to the embedded systems. Whereas coming to the cost part, processors are high cost and due to its external components interfacing, whereas controller it is cost a little bit cost is low because it has all inbuilt in one chip. And coming to the application part, processor it is used for general purpose computing, whereas microcontroller it is expressly used in the embedded systems and used for IoT applications, automotive, etc. And in the processing power, processor goes with higher, that is higher because it more useful for complete complex task, and control is used in a lower processing power because it is a task specific and which is used especially in the embedded systems. In next lecture series, we can discuss deeply about the individual microcontrollers and microprocessors with their specifications. Thank you.